Today we're going to talk about reference angles. So let's start by looking at our 4 quadrants. And we'll begin in the first quadrant. And we're going to take a look at our 3 trig ratios. Now, we know that r represents a radius, which is always positive. And in the first quadrant, all of our coordinates are positive, so both x and y will be positive. So each ratio would turn out to be a positive number because they're comparing positives to positive. But in the second quadrant, things are going to change a little bit. We've got sine, cos, and tan. Now r is still positive, x is negative, and y is positive. So sine will continue to be positive, but cosine will be a negative because it's got an x. And tangent is the ratio of a positive to a negative, so that will also be negative. So sine is positive in the second quadrant. Moving on to the third quadrant. R is always positive, but now we're looking at negative x values and negative y values. So we've got a negative to a positive, again a negative to a positive, but both y and x are negative, so the quotient will be positive. So tangent is positive in the third quadrant. Last one, we've got sine, cosine, and tangent. R is still positive, x is positive, but y is negative, which means that sine would be a negative value, cosine positive, and tangent negative. So here cosine is positive. Now let's go back around real quick. In the first quadrant, all of them were positive. In the second quadrant, only sine was positive. In the third quadrant, only tangent was positive, and in the fourth quadrant, only cosine was positive. And you might remember that you learned this mnemonic last year. You've got all students take calculus, and that's going to help you remember which functions are positive in which quadrant. So here's a little example problem. Let's say we're given that the tangent of an angle is negative 5/4, and that the cosine of that same angle is positive, and we need to find the sine of the angle. Well, first I'm going to set up my axes. And I'm going to notice here that tangent is negative, but cosine is positive. So cosine is positive in the first and the fourth quadrants, but it's only in the fourth quadrant that tangent is also negative. So I'm going to draw my angle here. Now if we continue with our picture and complete a triangle, here's our angle. We know that tangent must be equal to negative 5/4, but we also know that tangent is the ratio of the opposite side to the adjacent side. So we can start labeling that opposite, theta, should be our 5, and the adjacent should be our 4. Except we have to deal with the negative. We have to decide if the negative is assigned to the 4 or the 5. And the answer is that it's assigned to the 5 because this is going in the negative direction in the fourth quadrant. Now the length of this segment is positive 5, but the corresponding coordinate is going to have a negative 5. Now in order to find the sine of the angle, we're going to need that hypotenuse. So let's use our Pythagorean theorem here. We're going to have negative 5 squared plus 4 squared. So we get 41 Okay, radical 41. So, sine would be opposite over hypotenuse, or rationalized, that would be negative 5 over, or radical 41 over 41. Okay, so now reference angles. A reference angle is defined as an acute angle that's created by the terminal side of an angle and the x-axis. So, let's start off with an angle in the second quadrant. So here we go. Here's our angle. This here is theta. Here's the terminal side of theta. Here is the x-axis. So the reference angle is this angle right in here. Now the way we would calculate the measure of that angle is we would take the measure of this angle, theta, and subtract from 180 degrees. So this reference angle in the second quadrant would be 180 minus the angle, or pi minus the angle if we're working in radians. All right, let's take a look at the third quadrant. Okay, here's an angle in third quadrant. There's our theta. And remember, our reference angle is created by the x-axis and the terminal side. So now the reference angle is right in here. So the way we can calculate the measure of that angle is we can take the entire angle theta and now subtract out the 180, and we'd be left with this little piece here. So that would be theta minus 180, or theta minus pi. All right, one more in the fourth quadrant. Again, here's our angle in standard position. This is wrapping all the way around. So this is theta. The reference angle is made by the terminal side and the x-axis, so it's this little angle right in here. And the way we can find that is by taking the entire rotation and subtracting out the angle, or that would be 2 pi minus theta. So in order to find a reference angle, you need to first determine in what quadrant that angle terminates, and then subtract accordingly, either 180 minus theta, theta minus 180, or 360 minus theta. Okay, so in summary, what you learned was that all trig functions are positive in the first quadrant, sine in the second, tan in the third, and cosine in the fourth. And you learned that a reference angle is the angle that's formed by the terminal side of an angle and the x-axis. So here's the reference angle. And you learned that in order to find the measure of a reference angle, you would, in the second quadrant, subtract from pi. In the third quadrant, add pi. And in the fourth quadrant, subtract from 2 pi. Now in this graphic here, they included the first quadrant, which I did not when I was talking about, because the angle is its own reference angle. So there's no need to calculate anything for the first quadrant.